Okay, we're looking at the 10C practice test today. Question 1, multiple choice section says, suppose that the population of the scores of all high school seniors who took the SAT math test this year follows a normal distribution with mean mu and standard deviation sigma equals 100. You read a report that says, on the basis of a random sample of 100 high school seniors that took the SAT M test this year, a confidence interval for mu is 512 plus or minus 25.76. The confidence level for this interval is what? So the way you want to start on this problem is looking at the error amount, which is 25.76. And the formula for error is z star times sigma over the square root of n. You use this formula because you know it's normal and because you know sigma, so you're in 10.1. This formula can be found in 10.1. The error is 25.76. Your z star is unknown, but you know that sigma is 100 and your sample size is 100 also. Doing some algebra, 100 over the square root of 100 is just 10, and then you're going to divide both sides by 10 and you get 2.576, and that's one of the values you should have memorized, which is a 99% confidence level. Question 2. The government claims that students earn an average of $4,500 during their spring break from studies. A random sample of students gave a sample average of 3,975 and a 95% confidence interval was found to be 35.25 less than mu less than 44.25, meaning that the mean is between 35.25 and 44.25. This interval is interpreted to mean that what? And the answer here is the concept of a confidence interval is that if you repeat your survey many times, then about 95% of those confidence intervals will contain the true population parameter, which for us is the value of the average earnings of students. So number 2 is D. Question 3. Many television viewers express doubts about the validity of certain commercials. In an attempt to answer their critics, the Timex Corporation wishes to estimate the proportion of consumers who believe what is shown in Timex television commercials. Let P represent the true proportion of consumers who believe what is shown in Timex television commercials. If Timex has no prior information regarding the true value of P, how many consumers should be included in their sample so that they will be 85% confident that their estimate is within 0.03 of the true value of P? So there's a couple things you got to look at in order to be able to figure out this problem. The first being, if you have 85% confidence, I sketched a curve for what that would look like. Each tail is going to be 0.075. I want to find the z star value. So the way I found that is I did inverse normal on the calculator, and you want to find this value right here. So you're looking at everything below it, which would be 0.85 and the left side tail. You add those together and you get 0.925. And your calculator will tell you that z star is going to be 1.4395. So then I'm thinking, all right, I need my error to be within 0.03. So I'm using the error formula, but now they're talking about P, so proportions. So we are looking at 10.3, section 10.3, and the error formula there is z star times the square root of PQ over N. And so I started plugging information in. I knew my error was 0.03. I know my z star, and I'm finding how big the sample should be. So I'm solving for N, but that implies that I have to also know P and Q. But I went back and I looked at this problem a couple times at first, and I was like, I don't know what P and Q are. They don't tell me what they are. But the key to figuring that out is they say Timex has no prior information about the value of P. And when you did your reading of 10.3, it says in there that when you don't know what P hat is, that you should use 0.5 as your guess. So I'm using 0.5 for P hat, which means I'm also using 0.5 for Q hat. So when I plug those numbers in and I do my algebra, I get that N is 575.6, which rounds to 576. So my answer is C for number 3. Question 4 says a polling organization announces that the proportion of American voters who favor congressional term limits is 64%, with a 95% confidence margin of error of 3%. If the opinion poll had announced the margin of error for 80% confidence rather than 95% confidence, this margin of error would be what? So basically they're saying, what if we lowered the confidence? And we talked about this in class one day. Basically, when you have less confidence, you have a smaller margin of error. You're not as confident, so there's a fewer values that your true answer could take on. So our answer for question 4 is B. Our margin of error will also be less than 3% because we require less confidence. Question 5. Suppose we want a 90% confidence interval for the average amount spent on books by freshmen in their first year at a major university. The interval is to have a margin of error of $2, and the amount spent has a normal distribution with a standard deviation sigma equals $30. The number of observations required is closest to what? So Z star for 90% is 1.645. That's a value you're supposed to memorize from 10.1. Then I used the error formula. Error is Z star times sigma over the square root of n. Plugged in my values. Error is $2. Z star is 1.645. Sigma is 30. They tell us that. And then just manipulating this with algebra, you're going to get n is about 609. Question 6. The college newspaper of a large Midwestern university periodically conducts a survey of students on campus to determine the attitude on campus concerning issues of interest. Pictures of the students interviewed, along with their quotes of their responses, are printed in the paper. Students are interviewed by a reporter roaming the campus, selecting students to interview haphazardly. On a particular day, the reporter interviews 5 students and asks them if they feel there is adequate student parking on campus. 4 of the students say no. Which of the following conditions for inference about a proportion using a confidence interval are violated in this example? The first thing that sticks out to me is this is not a simple random sample. If kids are on campus, it means likely if they commuted that they had a parking spot, but also maybe they are just living on campus and they don't need a parking spot and they're going to be biased in some way. So this is definitely not a simple random sample. So initially my instincts would be to just mark A, but then I logically realized I need to look through all of the choices. And I looked at B. B said the population is at least 10 times as large as a sample. My sample was 5. I'm sure there's more than 50 students that go to a large Midwestern university, so it's not B. NP and NQ being greater than 10. Well, if my sample is 5, and P and Q values have to always be between 0 and 1, so the largest possible value I could have for either P or Q is basically 0.99. If I did 0.99 times 5, I'm going to get something that's less than 10. So this C option is violated also, which means that my answer for this is E, more than one condition is violated. Question 7, a 95% confidence interval for P, the proportion of Canadian beer drinkers who prefer Lion Red, was found to be 0.236 to 0.282. Which of the following is correct? So I read through the answer choices. Answer choice here is, we are reasonably certain that the true proportion of beer drinkers who prefer Lion Red is between 24 and 28%. Question 8, what is the critical value T star that satisfies the condition that the T distribution with 8 degrees of freedom has probability 0.10 to the right of T star? So if there's 8 degrees of freedom, that means n is 9, but you don't really need that to do this problem. If 0.8 is to the right, 0.1 is to the right, that means there was also 0.1 to the left of your interval. So there's 0.2 together on the outsides, which means your interval is 0.8. So then I just went to table B in my packet or in the cover of the book, and you're looking at the right side tail, 0.1, and you're comparing it to 8 degrees of freedom, and you'll find that the value that you get is 1.397. That's your critical value for T star. All right, on to the free response questions. Question 9, you measure the weights of 24 male runners. You do not actually choose an SRS, but you're willing to assume that these runners are a random sample from the population of male runners in your town or city. Here are their weights in kilograms, and we need to construct and interpret a 95% confidence interval from mu, the mean of the population from which the sample is drawn. So anytime we're doing a confidence interval, we got to follow the 4 steps of the inference toolbox. Step 1, the parameter. What are we trying to find? We're trying to find the true mean weight of all the male runners in this town or city. Step 2, conditions. 3 conditions: SRS, normality, independence. SRS, They tell us it's not an SRS, but we're willing to assume that they're a random sample. So that's going to give us a little bit of caution when we're completing this problem. For the normality condition, it doesn't tell us our data is normal. So what you need to do is take all these numbers and put them in your calculator in stat edit, and then look at the box plot. And when you do that, you'll see that the box plot is pretty symmetric, and there's definitely not any outliers, which allows us to assume normality. The third condition, independence, you just need to say that you need to make sure that all the male runners that you select are independent. They must be independent. And then we're going to say what kind of test we take. We're going to do in step 3, because we don't know the standard deviation of the population, we're going to do a one sample t interval. So we have we have sample data, so we have a sample standard deviation, S, and we have sample mean, x bar. So our formula is x bar plus or minus t star times S over the square root of n. X bar and S are found from doing one variable statistics on your calculator after you've put all the data in. I found those numbers to be 61.792 for the average and 4.808 for S, the sample standard deviation. We are looking at 24 people, which means we have 23 degrees of freedom. And so then looking at my table for 95% confidence, my t star value is 2.069. Then I'm just plugging the numbers in this formula, and that gives me an interval of 59.761 to 63.823. Last step 4, interpretation. We're doing 95% confidence, so we are 95% confident that the true mean weight of all the male runners in the town is between 59.761 kilograms and 63.823 kilograms. Part B, explain the meaning of 95% confidence. What that means is that we are using a method that will capture the true population mean in 95% of all possible samples of equal size, being 24 in our problem. And moving on to question 10. An association of Christmas tree growers in Indiana sponsored a sample survey of 500 randomly selected Indiana households to help improve the marketing of Christmas trees. One question the researchers asked was, did you have a Christmas tree this year? Of the 500 respondents, 421 answered yes. And we're doing a 90% confidence interval for the proportion of households who had a Christmas tree. Step 1, for our parameter, we want to find the true population proportion of Indiana households who had a Christmas tree last year. Our conditions, step 2, SRS normality independence. SRS, it says that these households were randomly selected, but it's not an SRS, so we're going to proceed with caution. The normality condition, when you're doing proportions, you have to check that NP and NQ are greater than 10. N is 500, P is 421 over 500, so NP is just 421, so Q is 79, NQ is 79. Obviously both of those are over 10. The independence condition when you're doing proportions is that the population has to be at least 10 times the sample, and our sample was 500. There's definitely 5,000 at least households in the whole state of Indiana. We're doing a one sample Z proportion confidence interval. We'll make sure that we're doing proportions. So our step 3 calculations would be P hat plus or minus Z star times the square root of PQ over N. P is 421 over 500, that's 0.842. Q is 1 minus that number, which is 0.158. When we're doing 90% confidence, Z star is 1.645. We're just going to plug these numbers in the formula. We get this interval, 0.815 to 0.869. Last thing, step 4, your interpretation. You are 90% confident the true proportion of Indiana households that had a Christmas tree last year is between 0.815 and 0.869. And that is the whole 10C practice test.